All right, we're going to start on some trig today. People always act like trig's going to be this really hard class. It really isn't a hard concept. It's just a little bit of algebra and geometry put together. We're going to start with just some very basics today. All of the triangles that we're going to see today are right triangles, and so here's a picture of a right triangle. The angles are named with capital letters, and the sides are named with lowercase letters. So what we know about this right triangle, the angle relationships, is we know that they all add up to 180. So if I add angle A and angle B and angle C together, you know you're going to have 180 degrees. The other thing that we know about triangles comes from 8th grade, and that is the Pythagorean theorem. We know that a squared plus b squared equals c squared. So those are some things that we'll look at a little bit more, but basically those are the things we already know how to do with triangles, and so this is going to show you something new. The idea of trig is based on similar triangles, and specifically what we're going to look at is the right triangles. The ratios of sides are always going to be proportional if the angles are the same. And so that's where trig comes from and the basis of what we're doing. And there's some great videos that explain that part better than me. I'm just going to go through the nuts and bolts of what you need to be able to do. All right, so over here where it says trig ratios, we've got this box, sine, cosine, tangent. You'll see down here abbreviations, SIN for sine, COS for cosine, and TAN for tangent. They abbreviate those basically just so they'll fit on calculator keys. There's really no other reason for that. That's how that happens. But we still call it sine, cosine, tangent is not sin, cos, and tan. That bothers me. All right, so sine is the ratio of the sides opposite your angle to the side that is your hypotenuse. So sine is opposite side over hypotenuse. Cosine is the adjacent side over the hypotenuse, and I am abbreviating just a little bit. And then tangent is the ratio of the side opposite over the side adjacent. Now, which sides are opposite and adjacent depend on which angle you're using. And I sort of think about if you're standing at that angle and looking out, which side is next to me, that's adjacent. Which side is opposite me, that's opposite. And so we're going to go through this twice, once using angle A as our angle in question, and then once using angle B. And I'm going to color code a little bit. You're not required to do that. I just think it helps some people. So all of these problems down here where we have angle A, we are pretending that we're standing at point A and we are looking out across the triangle this way. All right, so I'm going to use my pencil to label this because it will change a little bit. So the side opposite A is the side that's across, so you can think of it being all the way across. And so the 3 would be my opposite side. And then 5, if you see this, it's the longest side, and it's across from the right angle. That has to be your hypotenuse. And then this side right here that makes up angle A but is not the hypotenuse, that is the adjacent side. So the two legs that make the right angle are opposite and adjacent. Opposite is across from your angle, and adjacent helps to make the angle. All right, so basically what we're doing is we're going to write a bunch of fractions. So sine of A, sine is just opposite over hypotenuse. So we said the opposite was this side over here, so that's 3. And the hypotenuse is 5, and so my answer is 3/5. You can also change that to a decimal, make that 0.6, but we're not going to go into that today. We're just going to leave them as fractions. So cosine of A, cosine is adjacent over hypotenuse. That's going to be 4/5 because adjacent is 4, hypotenuse is 5. And then tangent is the ratio of opposite over adjacent, so we will have 3/4 or 3/4. Okay, so that's if we are looking at angle A. Now, if we suddenly switch our angle to angle B, things are going to change. So I'm going to highlight B in orange and all of these in orange, and I'm actually going to erase where I have the opposite and adjacent, because it changes if I'm now standing over here at B. I always think of this big triangle. I'm standing here and I'm looking out this way. And the hypotenuse does stay the same for everything. It's always the hypotenuse. It's the longest side. It's the opposite and adjacent that change. So if I'm looking from the position of angle B, now this side that is 4 is my opposite side, and the side that is 3 is my adjacent side. So that changes. Opposites across from B, adjacent is next to B. Adjacent means next to. It actually makes up part of B. So then that just changes what these fractions are going to be. So sine B is opposite over hypotenuse, and so the opposite from B is 4, hypotenuse is 5. Cosine B is adjacent over hypotenuse, so that's 3 over 5. And then tangent B is opposite over adjacent, and so that will be 4/3. Now just a word about improper fractions. You want to leave them as improper fractions. So I'm trying to write leave improper, but I'm running out of space here. So go ahead and leave those improper. You do not want to change it to 1 1/3. You also don't really want a decimal on thirds either, because it's a repeating decimal and you'd have to round it off. We'll just use the fractions for what we're doing today. So there's a few patterns you can observe here. If you look, sine A and cosine B are the same, and cosine A and sine B are the same, and that's because we have all the same sides. We're just looking from a different angle. You'll also notice that tangent A and tangent B are reciprocals. They are reciprocals of each other. If you flip over 3/4, you get 4/3. Okay, now, this is not how I learned, but a lot of students think that this helps them. There is a mnemonic device called SOHCAHTOA, and you have to be able to spell it this way. So just to explain what this is, the SOH, basically, if I have sine, that's opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I guess I can just take this down to just S. And so that's where they get the SOHCAHTOA. So if you just say that H really, really strong, SOHCAHTOA, then you can get the H's and the spelling in there. You can just memorize them. That's the way that I learned, but some people like using this mnemonic device. It helps them memorize it. And I will reference it a few times because it's just a nice thing to go back to. All right, so let's look at a different right triangle. Here we go. So let's go ahead and label our sides. And so we are going to look at it with sine and, with angle A and with angle B. So I'll go ahead and use my color coding for this. So we're going to start with the angle A. So a good place to start labeling these is the hypotenuse, because the hypotenuse is always the same. It's always the longest side. It's always opposite that right angle. So the 13 is my hypotenuse no matter what. Then if I go to A and I just look across, what side does not make angle A? Well, that would be this side over here, 5, so that's my opposite side. And then the 12 is sort of the one that's left over, that's adjacent. So if I go through all of my, my trig ratios, sine is opposite over hypotenuse, and so I'm going to have 5 over 13. Cosine is adjacent over hypotenuse, and so that will be 12 over 13. And then tangent is opposite over adjacent, which is going to be 5 over 12. Now, if you're clever and you have to do all of these anyway, you could switch these around to do the other 3, but I'm going to go through the process because when we get below, we're not going to do all of these every time. So you need to know, well, how do I decide what's what? So if I change, and now I'm looking for trig ratios with respect to angle B, the hypotenuse stays the same, but the side opposite B is now 12, and my adjacent side is now 5. And you can label this however you want. Some people just do H, O, and A. Some people use the abbreviations I have up there. It's whatever works for you, just so that you have it. Okay, so sine is always opposite over hypotenuse, and so that'll be 12 over 13. Cosine is adjacent over hypotenuse, so 5/12. And tangent is opposite over adjacent, so 12/5. And again, leave that improper. You can reduce fractions. So if I had, let's say, 5/10, I would want to go ahead and reduce that fraction, but leave it improper. So reduce, but don't change it to a mixed number. All right, so now we're going to look at some problems that look a little bit more like what you'll see on the assignment. So it says find the value of each trigonometric ratio. So on number 1, they just say find tangent C. So I'm not going to do all of those that we just did. There's just going to be one fraction. Sorry, my notebook slipped. So here's tangent, here's C. So if I label all of my sides, 41 is the hypotenuse, 9 is across from C, so that's opposite, and then the 40 would be adjacent. So if I think about SOHCAHTOA, T-O-A, tangent is opposite over adjacent, so I just need 9 over 40, and it's just that one fraction. That is literally it. Okay, so then if I go over here and we're doing sine of A, here's angle A. I like to label all 3 sides no matter what, just because it's just what I do. So 35 is my hypotenuse. Opposite A over here is the 28, and then adjacent to A is that 21. And so if I'm doing sine is opposite over hypotenuse, so my opposite is 28, and my hypotenuse is 35. Now, you might not recognize this with 28 and 35, but both of those divide by 7. And so we are going to reduce the fractions. So it reduces down to 4/5. So don't change improper fractions to mixed numbers, but do reduce the fractions. So if you want to write reduce in your notes, not a bad idea. Okay, so if I go down here and they want cosine of angle A, there's my angle A. Let's label things. So 20 is the hypotenuse. Across from A, opposite A, is that 16. That's my opposite side, and then 12 would be adjacent. Since it's angle A, putting the A there is a little confusing, but I think you guys hopefully will follow. So cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And so we are looking at 12 over 20. So again, we want to reduce this. Both of those divide by 4, and I get 3/5. You could also divide by 2 and divide by 2, which is the way a lot of you were taught, and that's totally fine. Just make sure you reduce it all the way. All right, and then last but not least, another cosine problem. Here is angle X. They want cosine of X, and cosine is adjacent over hypotenuse. So if I'm looking, 41 is my hypotenuse, 40 would be my opposite, and this 9 over here would be my adjacent. So I would have 9 over 41. And 41 is prime, so I know that that does not reduce. So we're just looking to make that ratio, or in other words, a fraction for each of these. And then it will build on this to solve for some missing sides in the next lesson.